Hi guys, Dan here, my son Andrew behind the camera. And today we've got some heated rear mirrors that don't work. I'm just going to take you through the steps I would use to diagnose this properly. This is actually my own car, so using it as a bit of a guinea pig. I'm not going to lie, I've been here before, I already know what's wrong with the car, but I'm just going to talk you through it as if I was fresh on the job. Okay, so straight off, the right hand mirror and the left hand mirror are both in up. So my first thoughts on that was, have we got a power supply issue? So a relay, a fuse, something along those lines, maybe even a main harness connector unplugged. I don't have the fuse specification chart to hand, so I can't go straight into a fuse, but that would be my first protocol. Keep it simple, straight to the fuse, should make sure they're not blown. Second step is what I'm going to show you here. I'm going to go straight to the mirror back and test for power ground to the heated element when the system's switched on. I'm going to cheat a little bit. I normally use a test light, however I've got the Power Probe 2 here, or Power Probe 3 even. It just basically is a glorified test light with a voltmeter connected. It means you touch power with this, the lights are right red, and it'll actually give you a voltage reading. Touch ground, you're going to get the green light, and again a voltage reading if you had an elevated ground issue or something like that. So it's like a mini multimeter and a test light rolled into one. Plus you can power it up and give it a ground whatever you're testing, which is handy. Okay, so straight away I'm going to pull this mirror off. It's obviously already pre-loosened. You can see here there's our wiring connectors to the back of the mirror heater, which are connected there. We'll just pop that down there for a second. First stage is check, see what we're actually getting to the mirror. So we turn the ignition on. I'm only expecting a ground at this point on one of these. I don't know if you can see that there. So the light's gone green, that means we're on a good ground, and it's showing us we've got 0 volts on that line. Again, good ground, that's what I'd expect to be seeing. Now this one should be power, but we've got 1.1 volts, and that's because the engine's off. We'll switch it away from the mirror position first. So the engine's off, so the BCM will actually cut power to the heated rear screen and the heated mirrors to save power with the engine off. And we switch that back on. Switch the mirror heaters on. This control switch, we'll test it again. So we've got a good ground on the brown. On the grey, there we go. You see that light's lit up red. 14.3 volts as well, battery voltage. This would normally, I've got this on mute, this would normally make a sound for power and for ground. Makes fault finding really quick and easy with this tool. Second stage, now it's going to be possible, in some cases you're going to come across a wire that may have battery voltage on or a voltage on, but it won't, the component still won't be working. So you'll have what looks like a good ground, and you'll have what looks like battery voltage, but the wire will be damaged, there'll be high resistance in a connector somewhere, so you need to put a load on that to make sure the actual circuit, the integrity of the circuit's still there. So what will happen is you might see 12 volts, you put a test light to it, and the test light won't light, and you'd be like, why won't that light? And it's simply because the connection in that wire is good enough for voltage to show on it, but it's not good enough to carry a load. You'd normally use an incandescent test light for this. This is my test light. It's just a 501 bulb and 2 connectors basically. Simple as you like. We're just going to bridge that across the connectors and turn it on. The bulb lights, I know it can carry a load. It's a bit hard to show you in this situation. So we turn the mirror heaters on. Need a third hand. Hopefully you can see this. So there we go. So that tells me everything I need to know about the circuit. I know it can carry a load. The power's good and the ground's good. Just confirm what the test light's already told us. We'll just switch the engine off for a second. Okay. Now, as I said before, we're definitely overkilling this. If I was at work and I was going through this job for quickness, I'd already know I was fitting mirror glasses to this, given the fact our power and grounds are good. The only thing left could be the mirror, but just for the hell of it, we'll run through component tests. So we have down here digital multimeter. Turn that to ohms. Wake it back up. I've been sat here waiting to film for so long it's cut itself off. We're going to do a resistance test through the mirror. Basically ohm it out, see what it comes up with. And what do we have there? 73.4 ohms. Now that figure means absolutely nothing to me, with nothing to compare it to. So up here, as I said before, I already know what's wrong with this, but we'll just go through the steps. We'll see what a good one looks like. Hopefully this won't say 73 ohms. I'm going to look a bit foolish in the camera. 14.6 ohms, 14.7. So there's a decent difference there. Obviously, as we'll see, I'm going to test this now. The higher the resistance, the lower the current. The lower the current, the less the component's going to work. So that's the new one. I'll just pop that up there for now. Now what we have here in front of me is basically just an ammeter. If I can do this efficiently, I'm just going to set up a bench test, nice and professionally on my lap, sitting in a car. Ground to ground. We're going to put the amp probe around the negative lead, so you can follow what I'm doing here. Basically I've got the power probe. I'm going to power this old mirror glass up on my lap, and I'm going to use the ammeter, the amp clamp, to test how many amps I'm actually drawing. So that clips around the wire, look like that. Turn the amp clamp on, always zero it. Actually I'll pop that down there so I can see what I'm actually doing. We connect the ground. That's the good thing about this tool, it allows me to power components up off the car so I can see what's actually happening with them. Right, so if I take the camera off under, I'm going to just show you, I'm just going to make the circuit with this, and we're going to see how many amps it's pulling on the scope up there. So I'll keep you focused on the scope. So here's the figures here. This is live, this is maximum, this is minimum, and we'll see how many amps we're pulling through here. Can you just put your hand on that for us, Andrew? Just so it doesn't move. But like I said, if I keep hold of that, I can actually send power to a unit. So I'll just make contact with that and just keep you focused. Just give us a second, I'll pull this. I'll curse it up so you can actually see what's happening. I'm on a 20-second scale, so you can actually see what's happening there. Whoops, need to invert that. I'll drag that back down again. Okay, so right now we're pulling 0 amps. We're pulling 0.21 amps, which is 210 milliamps, with 240 milliamp peak, which is nothing at all. And if I sit here for 60 seconds or so, the mirror's not going to warm up. As I've said, I've already pre-tested this. Now, like I was saying, this is complete overkill. I wouldn't do this for heated mirrors normally. I'd already have the new part on there. But just to show you the difference between the two, we swap this out now. When we go to the new part, you just grab that new part there, Andrew. Just slipped on the dashboard out of my reach. Okay, so if I get you to put your hand there to keep it steady again, please. And we connect this one back up. We already know the resistance reading's different. We connect that back up there. Get you focused on the scope. And there's our maximum figure on the left. Sorry, on the right, 0.24, 240 milliamps. And if I power this up, so the scope shoot right up to the top. 830 milliamps live with 840 milliamps maximum. That's a big difference, and I can actually feel the mirror warming up on my leg as it's sitting here powered up. So guys, that's basically it. That is how I'd go about diagnosing any component in the field. Obviously, like I said, what I've been showing you here with the scope and the amp clamp is complete overkill for what we're doing. It would simply been a case of power and ground tests, and then we're putting mirror glasses in it. I assume because of the design of the switch, whereas in most cars I've seen before, the mirrors are linked to the heated rear windows, so you'd have to actually activate the heated rear window, then your mirrors would come on. The design of this car is slightly different in that the mirror adjust switch, the rear position for that is heated mirrors, which are completely independent to the rear screen. So if you were to select that and then drive off as you would, obviously they'd time out after a while, but every time the switch is left in that position, every time you turn the ignition on, your mirrors are on. So I assume it's just burnt them both out. So we'll get these fitted, and the system will be fully operational again. As I say, feel free to criticise in the comments. I'm completely overkill on this. I would never do this. Normally it would just simply be a case of power and ground tests and new components. Thanks for watching.